one more seminar. Today we have Ana Espinola-Arredondo from the professor at Washington State University. Okay. She has been working in environmental economics and game theory. She has a lot of publications in very nice journals, and today she's going to present a paper on regulating the Stackelberg oligopoly with time-persistent pollution. Okay.
Yeah, absolutely. So first of all, thanks for having me today and thanks for coming. So what we will do today is to revisit the typical Stackelberg model. So I want you to think about the Stackelberg model in which we have a leader and a follower, and we will examine how this particular model is affected when we have regulation in place. All right? So that's the idea. So we will start with a very basic model. I'm sure that you have already seen that. And then I will start adding some flavors of environmental regulation to see how that changes. So this type of sequential competition in which you have a leader and a follower naturally arises in industries with innovation, in which the innovator is the leader in the model. So it has been well documented that this type of situation has been observed in marketing and transportation and supply chain industries. More recently, we are observing this type of sequential competition in high-tech industries. So think about energy storage, batteries, robotics, and the main characteristic here is that they are rapidly growing, so it's something that we should pay attention. And secondly, we have pollution in place. And then the next step is to think, okay, these industries are polluting, how can we address that problem? And one way is using environmental regulation, right? So the question that we propose here is, can we use the same type of environmental policy when firms compete simultaneously? Are we making any mistake as a regulator of regulating this type of industry, thinking that they are competing simultaneously instead of sequentially, right? So that's what we want to explore a little bit. And more specifically, what we want to examine here is how to regulate firms when they compete simultaneously. So what we know is that in this type of Stackelberg games, we usually have that the leader produces more units than the follower. It's something that we call the output advantage, leader's output advantage, all right? So given that, what we really want to know is how regulation affects the leader's output advantage. So now, what we will do in this paper is to disentangle this leader output advantage into two elements. I will be playing a lot with this. One of them is the first mover advantage, and the other one is the cost advantage. So once we recognize this, we can actually examine how regulation affects each of these elements, all right? So now I will also discuss the role of sequentiality in terms of the output decisions, and the way in which we will do that is to compare results with the Cournot case, right? And the next thing that I would like to discuss is the setting of the mission fee. In the model that I will present you, the setting of the mission fee is something that we call flexible, meaning that we set the mission fee for the leader and then for the follower. But we wonder in the paper what will happen if the setting of the mission fee is inflexible. If we only use one policy to tackle emissions from the follower and the leader. We will compare the results and see what type of inefficiencies are produced in that particular context. So in terms of the literature, this is the only slide that I have about the literature. I will summarize a little bit what has been happening in the last 40 years. So we have that regulation in the Cournot setting has been extensively analyzed. It started with Buchanan in 1969, and he considers a symmetric cost, and then there are a lot of derivations considering asymmetric costs, considering pollution intensities, and then other papers considering price competition instead of output competition. The difference between what I will discuss today and that branch of the literature is that we are considering a Stackelberg model. a sequential decision making process. Now, in terms of the Stackelberg game, the literature analyzing regulation in this context usually consider that the regulator sets the emission fee first, and then firms compete simultaneously, a la Cournot. And that's something different to what we are proposing here, right? Because what we are saying is that the regulator and the leader decides the emission fee and the output, and then the follower observing that decides its output level. So in that sense, it's different, what we are proposing. And then another branch of the literature examines the effect of environmental regulation on profits, and there you will find Porter and Vanderbilt and Farsing. All of these papers examine how the regulation can promote more innovation and product quality. Now, there is another part of the literature that examines corporate social responsibility or public image. Here we are proposing something different, all right? In this paper, what we are proposing is an alternative challenge for this profit-enhancing regulation, in which we focus on how the regulation is affecting the leader's output advantage and, as a consequence, its profit. All right? All right, so this is the literature, and hopefully I convince you that this is relatively relevant and it's a contribution that deserves your time. So during the presentation, we will talk about the model, and then after that, I will talk about the equilibrium behavior. So first, we will have a benchmark. And the benchmark is the classic, typical Stackelberg model without regulation. So I will go very fast there. Then I will stop a little bit and spend more time talking about the case of regulation, all right, with regulation. Then we will compare our results with the case of Cournot, all right. So how different the results are if we were considering that firms compete simultaneously. And then there is a lot of extensions that we develop in the paper. I will just verbally explain them. So we will consider the case in which emission fees are inflexible, in the sense that there is only one policy tool to address pollution produced by the follower and the leader. Then in the basic model, in order to keep things simple, we just assume one leader and one follower. A more complex context will be what if we have n leaders and n followers, and we examine that as well. Then we examine the case of product differentiation. In our model, we have homogeneous goods, but then we said, okay, and what if the leader and the follower, they sell differentiated products? How our results will be affected? We also explored that. Then we consider what if, instead of the leader having a cost advantage, the follower is the one that has a cost advantage. We also explored that. And finally, what if the leader is completely clean, doesn't pollute? So how our results change. So all these extensions are presented in the paper, but here I will just discuss some of them for sake of time. So we will start examining the model. It's a very basic, typical model in which we have an inverse demand function. You can see that Q is the aggregate output level. Then we identify the marginal cost for the leader and the follower. And we will allow for asymmetries, cost asymmetries. Remember, and this is an important point, is that we want to examine how regulation affects cost advantage. So in order to do that, what we will do is to normalize the leader's cost to be equal to 0, and we will define the difference between the follower's marginal cost and the leader cost as the leader's cost efficiency. That will help us to really observe what is the effect on the leader's cost advantage. That's the reason that we are making this arrangement. So every time that you see C, this C is denoting the difference between the followers and the leader's marginal cost, or as we call the leader's cost efficiency. In terms of environmental damage, remember that we said that, okay, these firms are producing some pollution, so there is an environmental damage in place. And it happens in the first and the second period. In the first period, it's a convex increasing function, which just depends on the output level produced by the leader. In the second period, we allowed for the environmental damage to be affected by the output level produced by the follower, but also a proportion of the output produced in the first period will stay in the environment and affect the environment in the second period. Notice one thing here. D, the D that you are observing there, is indicating the pollution intensity. We consider the fact that we have this D greater than 1/2 is because we want to focus on positive emission fees, right? So that's the reason that we have that assumption there. Now, in terms of time persistence, you again see that we are restricting ourselves to a particular range between 0 and 1/2, all right? So there is pollution intensity, but it's not so big. Again, the reason that we have this is because we want to avoid corner solutions. We want to be focused on interior solutions in which both of the firms are active, in other words. So now, if lambda is equal to 0, then the environmental damage only depends on the output level produced by the follower. If it is positive, then there is a proportion of the first period pollution that still stays in the environment. We allow for that in the model. All right, so this is the time structure of the game. In the first stage, we have that the regulator will choose the emission fee that the leader will face, T1, and then the leader responds choosing its output level. In the second stage, now we have the regulator again sets an emission fee for the follower, T2, and the follower responds choosing the output, Q2. So one thing to pay attention here, just to keep the same flavor of a normal Stackelberg game, the output is solved at the end of the game, all right? And this is a complete information game, the basic. All right, so here we have the social welfare, which happens in period 1 and 2. Why do we need the social welfare? To define this is because the regulator at the end of the day will have to set an emission fee. So the regulator will use this social welfare in the second period that depends on consumer surplus, producer surplus, third element tax revenue, and then the environmental damage that we already defined in the second period. Now, in the first period, the regulator is smart enough to anticipate what's happening in the second period, so it will account for that. Probably you are thinking why you don't have any delta, so we didn't want to overcomplicate this. We could have a discount factor. We don't have it here. Delta is just equal to 1, all right? So it could be multiplying, will not change anything. And then here we have the environmental damage that is happening in the first period, and also we have the total tax collection. It's important to have the tax collection there because then our policy will be revenue neutral, all right? So that's the reason that we are considering this. All right, the easiest case, which is the no environmental regulation, we start operating by backward induction. Remember that that's the way in which we solve these type of games. So in the second stage, the follower will decide its output level, maximize its profits, as everybody knows. An important thing to notice is that negative sign, which is denoting the fact that these two output levels are strategic substitutes. So meaning that if the leader increases his output level, the follower will decrease, right? And then in the first stage, remember operating by backward induction, the leader can anticipate this, considers the best response function of the follower into its maximization problem, and we obtain the output level in equilibrium. Something to notice here is the role of C. C was the leader's cost efficiency, all right? C is the difference between C2 and C1. So as the leader becomes more efficient, then the leader will produce less units, which means that the follower will have to produce less units, all right? So that's the only thing that I wanted to point it out. Important point, C lower than 1/3, meaning that, yes, they are asymmetric, but not so much. Otherwise, we will end up into a corner solution. All right, this is quite relevant for the presentation of the paper. And the reason is because I will be playing a lot with this, all right? So remember that one of our objectives is to identify the leader's output advantage. And the leader output advantage is defined as the output level produced by the leader minus the output level produced by the follower. So this is denoting no regulation, remember, the simplest case. So you can see that it's strictly positive. Remember that C is a positive difference. So this will be always strictly positive, meaning that the leader always produces more units than the follower. Not surprised there. what we can do is to take this difference and represent this, disentangle this difference into the first mover advantage and the cost advantage, and represent this as a line. This will help us a lot when I start introducing regulation, right? So the intercept of this line will be the first mover advantage, and you can see that when firms are symmetric, both of them have the same marginal cost. The only thing that the leader is getting here is the first mover advantage, right? But as firms become more asymmetric, as the leader cost efficiency increases, then you can see that the output advantage will increase, right? Okay, so then the basic question here is how is each type of advantage affected by the environmental policy, by this emission? That's what we want to examine. So what I will do now is to revisit the model that we were developing.
Sorry for interrupting.
Yes.
In Teams, people at home are not listening. So that's, you have to use the microphone. People at home are not.
I can use this.
Okay.
No.
Sorry.
No, it's okay.
Thanks.
So then, for those that were not listening, now I'm telling you the most important part, which is the introduction of environmental regulation, which is the most complicated. All right. So then I will start doing exactly the same that I was doing before. Remember that this is operating by backward induction, which is very simple. Basically means that you are solving the maximization problem in the second stage. The follower is deciding its output level. What is new here compared to the previous case is that now, yes, we have the same best response function, but the difference is T2. All right, so we have this additional burden that the environmental policy is imposing. All right, so it enters negative. So the intercept we know that will be lower of this best response function. So then we can see that the follower's best response function decreases in C and T, something new. So now in terms of the regulator, remember that the regulator has to choose the emission fee in this period. So what the regulator wants to do is to induce a particular social optimal amount. So it needs to identify a fee that maximizes the social welfare that I showed you and induces this socially optimal amount. And the T is this one that you have there, right? So let's try to make some sense of what we are obtaining here. This is positive for all parameter values. Why is that? Remember that I was saying, look, if we really want to focus on emission fees, we need to assume that D is greater than 1/2. So this part will be positive, right? And then we have that, of course, one maximum willingness to pay, one, this intercept needs to be greater than C. All right, so now, the question is how these parameter values affect the setting of the emission fee. So what we have there is the pollution intensity, just to remind you, which is D, lambda, which is the time persistence, and C, which is the leader's cost differential, or cost efficiency. Okay, so then what we observe is that this emission fee is increasing in lambda, is increasing in D, and is decreasing in C. So what does it mean? It means that when pollution becomes more damaging, so higher values of D, or more persistent, then the regulator will have to set a more stringent emission fee to control that, all right? So now in terms of C, if C increases, that means that the leader is more efficient than the follower. If you remember the best response function, that is telling me that the follower will produce less units. If there is a one-to-one relationship between output level and emissions, then it will emit less. So you don't require to set a very demanding, stringent emission fee. So that's the reason that we are saying that the emission fee is decreasing in C. As the leader becomes more efficient, the emission fee that the follower will face will be less stringent. All right, that's the idea. And then finally, we have the role of Q1. For Q1, we need to think two different points. We need to make two different points here. The first one is that as Q1 increases, the follower will produce less units. All right? So if the follower produces less units, then there is this, that will be the negative side for the follower. It will have to produce less units because the leader is producing more. The positive side is that producing less means less stringent, less demanding emission fees. At the end of the day, the first negative effect is more dominates the other effect, and the emission fee will decrease in Q1. All right, in the output level produced by the leader. Okay, so now we move to the first stage, and here we have again the leader deciding its output level, same than before. So focus on this output level that depends on T1. Remember that the first mover here will be the leader, and then we have the regulator in the first stage. So still we haven't identified T1. What is important to notice here is that this will be positive if and only if the emission fee is not sufficiently high, all right? It's not too demanding. So we will guarantee that the leader will produce positive units. It is also increasing in lambda and C. So it is natural to think that it will increase in C. If I am the leader, I am more efficient, then I will produce more units. In terms of lambda, what this is telling us is that the leader is anticipating that the follower will produce less units. Because if lambda increases, remember the relationship that I was describing before, if lambda increases, it means that more pollution stays in the environment, the regulator will have to set a higher emission fee to the follower, and then the follower will produce less units. So that's the reason that we have this positive relationship between Q1 and lambda. All right. So now we have the regulator. The regulator is able to anticipate all the relationships that I have been describing, and it needs to solve the maximization problem. The maximization problem, remember, is maximizing social welfare that I defined at the beginning of the presentation, and needs to induce this socially optimal amount. So first, what we are doing here is solving the maximization problem for the regulator, identifying the socially optimal amount, and then making that amount equal to this, right? That will give me the optimal T, the T that will induce the leader to produce that socially optimal amount. That's the way in which we are solving this. All right, so then we obtain all this, but what we really care about, and when we are doing these theoretical papers, is to examining these relationships between the parameter values and the results that we are obtaining. So we know that T1 is positive, and if we take the derivative of this T1 with respect to C, lambda, and D, we observe that it is positive as well. That derivative is unambiguously positive, which basically is telling us that when pollution becomes more severe or more intense, the leader also will face a more stringent emission fee, a more demanding emission fee. And it's increasing in C because, yeah, the regulator anticipates that if you are more efficient, you will produce more, so I will have to set a more stringent emission fee in order to make sure that you produce a socially optimal amount, right? Okay. So then, the question that we ask ourselves is which one is facing a more stringent fees, the leader or the follower? And we take the difference between these two emission fees that we obtain, and the result that we obtain is that difference is unambiguously positive, which basically is telling us that the leader will always face more stringent fees than the follower, which makes sense because the leader produces more, right? But then we present this as a line again. As you can see here, what we are trying, this will be the intercept, these are all parameter values, and this is the slope of our line. The reason that we are doing that is because we want to see what happens and make it very clear when firms are symmetric and asymmetric. When firms are symmetric, C equal to 0. So in a way, the emission fee for the leader is higher than for the follower because the regulator is trying to address the first mover advantage. It's not related with C, it's just related with the fact that the leader is the first one moving in this game. Now, if C is positive, so firms are relatively asymmetric, then what we have is that as C increases, T1 will increase more rapidly. The emission fee that the leader faces will increase more rapidly than the emission fee that the follower faces. And that's to address the leader's cost advantage, right? Okay, so then we are in the point in which we want to be. Because remember that one of the questions was how regulation affects the leader's output advantage. So again, in order to calculate this, remember how we did this with the simplest case in which we didn't have regulation. It was just the difference between Q1 and Q2. It's just, we're doing exactly the same here. And we are identifying, we are disentangled this difference into two elements, the first mover advantage and the cost advantage. And you can see that this will be the intercept of our line and the other will be the slope, all right? Think about the first figure that I presented you, because now we will start exploring a little bit more how that figure changes, all right? That's what I will do next. So the first figure that I was presenting you was this one without regulation, and I was claiming that this intercept is the first mover advantage, and as C increases, we have the cost advantage affecting the leader's output advantage. It's always in the positive quadrant, all right, indicating that it's always positive, the leader will always produce more units. Now, when we have regulation, you can see here, we focus in the simplest case first, in which we have no pollution intensity, all right, forget about pollution intensity. Lambda is equal to 0. The only thing that we want to examine is how the environmental damage or damage intensity affects this line. And what we can observe here is that the first mover advantage is completely eliminated by the regulation, right? So when firms are symmetric, when C equal to 0. C equal to 0 means that both firms have exactly the same marginal cost. Now, as the marginal cost increases, we can see that the leader's output advantage is positive and increasing, still below the case of no regulation. So regulation is affecting. It's clear that it's affecting the leader's output advantage. By the way, the reason that this is important for us is because we really want to predict when firms will oppose to environmental regulation. If you are the leader in the industry and you are able to anticipate all this situation, then you will oppose. It will be more difficult that they will accept an emission fee, all right? So that's what we are trying to capture here. And then, as you can see, as the environmental damage increases, so we move from D1 half to D1. That's just indicating that pollution becomes more intense, all right, more damaging. So if that's the case, I already discussed the fact that a more damaging emission will make the regulator to increase the emission fee. Right, so the policy will become more stringent. You will be, in a way, I don't want to say penalizing, that's not a good word. You will be charging a higher fee to the firm in that particular case. So then the slope will become flatter. Still positive, but it will be flatter than in the case in which D is equal to 1/2. All right, so what I will do next is just to summarize, just to make sure that this is clear, summarize what we have been discussing. So when there is no persistent pollution and firms are symmetric, what we observe is that there is no cost advantage and there is no first mover advantage, right? So regulation completely eliminates the leader's output advantage. Now when C is positive, now we have that there is a cost advantage, but it's smaller with than without regulation. Think about the flatter part of the line. All right, so what happens with higher D? So if D increases, the line will become even flatter, exactly, and then more stringent fees, especially on the leader, which produces more units. And then the output advantage will decrease even further. So now, this figure is representing the case in which lambda is positive. Again, lambda. What is lambda? It's the time persistence. And I'm trying to remind myself as well. Lambda is the time persistence. So you can see something curious here that we are observing. So if we assume that D is equal to 1, So we still, when lambda was equal to 0, remember that we were saying that the first mover advantage was completely eliminated. So the regulation completely takes away the leader's output advantage. Here is switch, actually. When firms are relatively symmetric, we could observe, instead of a leader's output advantage, a follower's output advantage, induced by the regulation, right? The follower will be very happy, and probably they will be favoring the regulation in that particular case. That's what we should expect. But that will happen if and only if they are very close in terms of a marginal cost, right? That was quite curious for us. Why? Why is that happening? And the reason is because, remember, T1 minus T2, it was unambiguously positive. The leader will always face more stringent fees than the regulator. And considering that the cost differential is relatively small, that stringent environmental regulation will switch the leader's output advantage to a follower's output advantage. That's what we are observing there. And this is just summarizing what I already said about that particular figure, right? Okay, so now the next step is to identify the output advantage comparing without and with environmental regulation. Now what we are taking is these changes and taking the change of the change. And the reason is because once we identify that that's positive, then we can claim that that's due to environmental regulation or to the emission fee, right? So, and then what we try to identify is whether or not this difference is positive. And what we find in proposition 2, that is positive for all parameter values. So again, it's something similar to what we were saying before, this reinforce or result that in fact regulation affects the leader's output advantage. And just to, we can rewrite this difference as the difference between first mover advantage without and with regulation. We know that that's positive, right? No doubt about that. Here, the cost advantage with regulation and without regulation, generally it's negative, meaning that the leader's cost advantage without regulation is higher than with regulation. But there could be some situations in which this can be positive, meaning that the regulation actually increases the cost advantage of the leader, right? All right. In terms of leader's profit, we also ask ourselves, okay, then what will happen if, and you know what, I'm saying all this, I'm thinking about working with Felix and thinking about the reviewers. By the way, you know that all these things is usually because you start thinking, okay, what if someone asks this? What if it's someone? So all these things are just to make sure that it's a what if, all right? So all the things that you will see is a what if. So the leader's profits, we wanted to know in which situations those will be positive, all right? They are strictly positive when we have regulation in place. And what we found is that it will be positive, the leader will earn more profits than the follower if this ratio is greater than this cutoff. What is this ratio? So remember that we know that the leader always produces more units than the follower, with and without regulation. So that ratio is always greater than 1, all right? Now, then we say, okay, that's true, but then we have two cases. One in which the leader is producing more than the follower and is obtaining higher profits with regulation, but we also identify a case in which the leader produces more units than the follower, and because regulation obtains lower profits than the follower. That's what this corollary is just saying. And then the idea here is to develop comparisons with Cournot competition, because my claim was, look, maybe the regulator sometimes is making some mistakes, all right, and is thinking that firms is deciding an environmental policy, thinking that firms are competing simultaneously, or they are simultaneously deciding their output level, when in fact they are sequentially deciding their output level. So in order to see the distortion in terms of the effect on the leader's output advantage, we need to compare the results. Now, number one still is talking about the leader, but as you know, in a Cournot model, there is no leader and follower, all right, because they simultaneously decide their output level. So now output decisions are without regulation are very standard. What we do here is just to examine the leaders or firms one output advantage when we don't have regulation, and you can see that it's just C. Of course, there is no first mover advantage because the setting of the game. So it is just related to the leader's cost efficiency, how symmetric they are. Now, with regulation, there are two cases that we need to consider. One, when firms are symmetric, so C equal to 0. In that case, what will happen is that the socially optimal is evenly divided between firm 1 and firm 2. So, which basically means that the emission fee that firm 1 and firm 2 face is exactly the same. Now, when firms are asymmetric, as a regulator, you need to deal with something else, right? The fact that one is more efficient than the other. So then you will set different emission fees. In this particular case, what we observe is that it is socially optimal to have only firm 1, the most efficient one, producing in the market. All right? And you will set some emission fees that will guarantee that. All right, so in terms of output advantage, with regulation, remember that before I presented the output advantage without regulation, which was equal to C. In this case, when firms are symmetric, there is no output advantage, all right? But when firms are asymmetric, we can identify an output advantage, which is strictly positive, meaning that firm 1, the most efficient, produces more units than firm 2. Right? Of course, there is no first mover advantage. So then, we try to do exactly the same that we did before, to take this change of the change, and if that's positive, that means that regulation is affecting firms 1's output advantage when they are more efficient, producing the good. And we have that that's positive if and only if there is a cutoff for environmental damage, all right? So graphically, what we are finding is that if the environmental damage is sufficiently high, right, in this area, and asymmetry is relatively important, all right, so firm 1 is more efficient than firm 2, then we will have that the regulation will be actually affecting firm 1's output advantage. However, if the environmental damage is not so significant or firms are relatively symmetric, we will actually have that the opposite, that the leader will produce more units, or the leader or firms 1's output advantage will be emphasized with regulation in the Cournot model, all right? So then the next step is to compare this with Stackelberg. And when we do that, then we observe two regions. One in which Stackelberg and Cournot provides the same results. So this region here is telling me, doesn't matter, it's not so dramatic if the regulator is considering simultaneous competition or sequential competition in output, because regulation will affect the output advantage in the same way. A little bit more for Stackelberg than Cournot, all right? However, if we are in this area in which firms are more symmetric, or the environmental damage is not so substantial, then you will have that considering simultaneous competition will actually provide firm 1 with an output advantage, with regulation than without regulation, right? So yeah, what this is saying is that, look, if we observe a market, an industry, in which firms are simultaneously competing, the environmental damage is not so big, and they are relatively symmetric, those firms will favor, actually, regulation. That's what this is saying. All right, so just, I will talk a little bit about some extensions here. First of all, flexibility of the regulation. All right, so remember that the way in which we understand flexibility is the fact that the regulator can set an emission fee in the first period and in the second period. All right. Inflexibility means that the regulator will set an emission fee that will induce the aggregate socially optimal. And it will be one fee for both, for the leader and the follower, all right? So what we know is that this will be suboptimal, all right? It's not the first best. If we calculate that fee, this is the fee that we obtain, okay? So you trust me that my calculations are correct, and that's the fee. But we really wanted to measure this flexibility. And in order to do that, what we did was to construct this linear combination between the emission fee that the leader sets in the case of a Stackelberg, which is more flexible, right, for in the first and the second stage, with the emission fee that I just found, which is more inflexible, is inducing this aggregate social amount, optimal amount. And we will multiply this by mu. So if mu is equal to 1, that's telling me that the emission fee will coincide with that in a flexible setting. If it is equal to 0, it says that the emission fee will coincide with an inflexible setting. And then you have intermediate cases, right, in which is more flexible, closer to flexible, or closer to inflexible. And what we will do here is to calculate the leader's output advantage with this linear combination. Graphically, what we obtain is something very intuitive, by the way. So you can see the graph there, and something that you are probably suspecting. As the emission fee, as the setting of the emission fee is more inflexible, we will approach to the case of a no regulation. So the output, the leader's output advantage under no regulation. Still below, of course, we are better off even having an inflexible regulator in place, all right? Because it will account for the externality. But if it is flexible, you can see that flexibility is talking about a mu that gets closer to 1, all right? So the leader's output advantage will be more affected. So again, if you need to think about this result, so what I am trying to say here is that if firms anticipate that the leader, it's very bureaucratic, right? So it's very difficult that we'll be able to set different emission fees across time, then they will favor more regulation than if you have a very proactive regulator that is constantly checking, all right? So that's what this is saying. Now, what if we have N leaders and N followers? Personally, I always think that this having M and N is just complicating a little bit more things, but it's important to know what happens, because in the reality you have several firms participating in the market. So I will just give you the result. So when we have that there are more leaders, more leaders than followers, then the leader's output advantage will shrink. The opposite is true if we have more followers than leaders, meaning that the leader's output advantage will expand, all right? But still the results are solid and consistent. So now what about product differentiation? What if competition is less intense? All right, so that's what this is telling us. So we are not selling exactly the same product in the market, we are selling a little bit differentiated product, so competition is less intense. So if that's the case, what will happen is that the leader's output advantage will decrease when products are more differentiated, and that's true because they compete less between themselves. But this holds with and without regulation, but the later will fall more substantially. Without regulation will fall more substantially than with regulation, which is something different that we obtained before. Now, what if the follower has a cost advantage instead of the leader? So in that particular case, what we will observe is that when firms are very symmetric, so C1 and C2 are relatively close, then the leader will hold an output advantage without regulation, but when we have regulation in place, that output advantage will vanish, all right? And that's, again, this is the case in which the follower now has a cost advantage compared to the leader. Now, the last extension, what happens if instead of having a polluting leader, we have a green leader? So if the leader is green, that means that we don't need regulation in the first stage, all right? So the regulation will only appear in the second stage for the polluting follower. So in that particular case, then in terms of the leader's output advantage, regulation will obviously emphasize this output advantage. The first mover advantage will increase, so this intercept will move upward, and the cost advantage will increase as well, all right? So now what I will do is just summarize, just to digest all the things that we have been discussing. So when we don't have regulation, the output advantage is larger in Stackelberg than in Cournot. That's what we saw. And the output advantage will decrease in the number of leaders, increases in the number of followers, and shrinks when goods becomes more differentiated, less intense competition. Now, what happens when there is regulation? What we obtain is that the leader's output advantage actually decreases when we have regulation in place, so this difference is positive. But this will expand in the leader's cost advantage, but shrinks as pollution is more damaging or more persistent, right? Now, in terms of regulation flexibility, larger flexibility will shrink the leader's output advantage, right? As we saw, as mu becomes smaller, larger, closer to 1, then we have the lines that I was presenting you goes down. And then when do we have the reversal of the leader's output advantage? When do we observe that regulation actually induces the follower to produce more than the leader? So we observe that case when we have that firms are relatively symmetric, if you remember with the lambda. Many leaders but few followers, that could be another case. Products are highly differentiated and the follower, of course, has a cost advantage. That was one of the extensions that we were analyzing. So then what's happening when we have the reversal of the output advantage? Of course, in this context, we should expect a strong lobbying against environmental policy by the leaders' firms in the market, right? Because they don't want that. So, and that's all that I have at this point. So if you have any question, just let me know. Yes, yes.
Well, first of all, it was very interesting, thank you. But I have a what if, sorry. First, you're penalizing productivity, I mean the taxes are penalizing productivity. Then I think it would be rational to assume that D is also a function of C. So if firms are more productive, they will produce less per unit of
that's a good point, actually. But if you're more productive, you will produce more units. So it's already captured by Q.
Yeah, but then maybe you have an area in which for T2, the policymaker is enforcing firm 2 to be more productive in order to lower C, and the opposite in Q1, it would be decreasing also with C, maybe, I don't know.
I will say that Q is already capturing the firm's efficiency level, the output level. Q1 and Q2 is capturing that. What you could say, and I don't want to do that, but you could say that D is related to lambda. It's a or lambda is a function, lambda is time persistence, is a function of D, all right? That, remember that Q is a choice variable, the others are exogenous, are parameter values. So that could be something that we are trying to explore a little bit more, and it's complicates things.
And I have another thing. What if the policymaker could not identify D, but knew that D is a function of C and Q?
That's another what if that is complicated.
Yeah.
Because then you are in a setting of incomplete information, right? And you have to construct some beliefs about that. And then that makes things more complicated. What we are trying to do, by the way, this is, and that's a good question, because what we are trying to do here is to open the door to this type of models, all right, in a simple way. So we are proposing a very simple model, which is easy to understand, and that you can capture that and start doing all these what ifs, all right? And one natural way to further develop this model is with incomplete information, right? Because it's obviously the regulator usually doesn't know the extensity, the extension of the environmental damage, how damaging that will be, right? So then there is some uncertainty about that you need to include in your model. Or maybe there is a probability, depending on the weather, in which D is less damaging, low or high, and you will have a probability in place that you need to consider in the model. That's a different way to twist this. Or you could have a leader that wants to trick the regulator and make the regulator believe something that is different. So you could have a signaling model as well. So yeah, those are interesting questions, by the way. And what we are the objective, the main objective of this paper is to start opening the door to this type of models, which are not quite examined in the literature, having regulation in place.
Another assumption related to uncertainty is that it is assumed that the marginal costs are known,
Yeah.
are firm, and I can imagine that you know more your own cost
Than the
cost
other.
of the
Yeah, absolutely, and you can add that because that will affect, by the way, the output decision level, and it will affect the regulation at the end of the day, right? And those are more realistic situations that we would like to capture. But again, the objective, the ambition of this paper is to first understand pretty well what's going on. That's our only objective here. We really wanted to know, in terms of first mover advantage and cost advantage, what's happening. Now we know, yeah, of course, regulation is affecting this, but then we can move a little bit more, right? And because if you think about the reality, there are some situations in which firms really oppose. There are other situations in which firms welcome environmental regulation. So maybe there are other things, which usually are related with incomplete information. Something that the regulator doesn't know, but the firms know.
I want to know, is it possible to consider the green investment in the model? Because consider the green investment
Abatement,
more
yes.
sustainable than the
Of
regulation.
course, that's another way to further develop this model, considering abatement. Because with abatement, you will make the fee that you face less stringent. So it's a way to reduce the cost, the additional cost that the fee is imposing. Yes.
Okay.
And even you can have a subsidy. Here we restrict ourselves to an emission fee, all right? I said D greater than 1/2. I only wanted to deal with that. But you could have a range of these that allowed for a subsidy as well in place.
Okay, and there is one extension you said to set the leader is green. So I really want to know. So there is no regulation means.
No, because if the leader is green, then there is no one-to-one relationship between the output level, Q1, and emissions. There are no emissions, all right? So in this model, it means that the leader doesn't pollute. If the leader doesn't pollute, there is no externality that you need to address in that context.
It's like
So-
the electric cars that are already clean.
So then there is no need to have an emission fee in place. The only one that is polluting in that context is the follower. And that's the reason that you have the regulator in the second place.
No question. Everything's clear.
Okay, thank you. Thank you, everyone.
Thank you very much.
for coming.